Okay, it's time for Ooey Gooey Fun Day. Today we're going to learn about slime, oobleck, and other non-Newtonian fluids. So if any of you would like to share about what you know or what you would like to know about slime or non-Newtonian fluids, now would be a great time. Okay. So it's time to make slime and oobleck. Okay, so it's very important to practice good lab. My apologies. It's very important to practice good lab safety whenever you are doing a science experiment. So today we are going to be practicing putting our hair back and tucking in any loose drawstrings or jewelry or long sleeves that might be getting in the way. It's also important that we don't eat or drink anything in our lab area and that we always wear our safety goggles if we have them. And it's also important not to waft the chemicals into your nose because in some scenarios that could be potentially hazardous. It's also important that you clean up your lab area and store everything properly and have the necessary supervision if necessary. So today, right now we're going to be making oobleck, which is a non-Newtonian fluid. So while you gather the materials of half a cup of cornstarch and 1/4 of a cup of water, I'm going to play this video while you guys gather your materials.
Okay, we're all set. Let her rip.
Hi!
Hey, check it out. It's just cornstarch and water.
They make up a non-Newtonian fluid, which is liquid, but solid under the percussive action of the speaker.
Okay, so I hope that you gathered all your stuff. What we are going to be doing is we are going to measure out a half a cup of cornstarch and pour it in a large bowl. And we're also going to be measuring 1/4 of a cup of water, and we're going to mix those together very slowly. So here's an instructional video. Hi everyone, it's time to make oobleck. So first things first, I'm going to put on my safety goggles, because safety first. Okay, and this recipe is going to call for cornstarch, water, and a dish to mix the ingredients in. You're also going to want a mixing utensil. So the procedure calls for half a cup of cornstarch and 1/4 of a cup of water. But any variation, you can use any amount as long as you maintain a 2-to-1 ratio. So you can cut or double the recipe. So first things first, I am going to pour out the measured cornstarch into a bowl to mix in. Also, it's important to be doing this on a surface that can get a little messy, so if you want to lay down a tablecloth so that you don't see anything while you play with it. Okay, next, I will be pouring in water. You're going to let it pour in there slowly. Okay, so you're going to slowly mix the cornstarch with the water. So make sure, it's hard to hear. Make sure that you're slowly mixing the cornstarch with the water. It's gonna get a little bit thicker if you stir too quickly. So make sure that you take your time and you're patient to make sure that everything is fully incorporated. So,
Are we supposed to put the cornstarch first and then the water?
You can put the cornstarch in the bowl and then slowly add the water to it. It doesn't really matter which order you put it in, as long as you're maintaining a 2-to-1 ratio of the cornstarch to the water, because if you don't use enough water, it's going to become too liquid. If you don't use enough water, it'll be too thick, and if you don't use enough of the cornstarch, it'll be too liquidy.
Okay.
Did it work for everybody?
We need more time to mix.
Okay, I'll wait. Just let me know when you all are ready.
Thank you. Thank you. Thank you. I have a question.
Yes?
Um, when should we put food coloring in if we have food coloring?
If you didn't mix it already, it'd probably be best if you put the food coloring into the water and then poured it in. But if you put the food coloring in afterwards and stir it really well, it should be okay, but I recommend putting it in the water.
I put too much water in it, and some of the cornstarch came out. So what could I use instead?
Is it really liquidy?
Yeah.
Just pour pour some more cornstarch in there and stir it and see if that helps. If it's still too liquidy, add a little bit more of the cornstarch.
Okay.
We're ready.
I'm trying my best to make it to slime, but it's not working.
Wait, to make it to slime? This
It was
isn't,
like stuck.
is it stuck? Is it sticky and stuff?
Yeah, it is sticky. We're all done too.
Okay, so this is Oobleck. It's not slime. This is a non-Newtonian fluid. So when you squeeze it, it's gonna be hard, and when you stir it, it's also gonna be like become thicker.
What's happening?
But when you're not stirring it and you just like slowly put your hand in it, it's gonna be liquidy. So it's not gonna be like slime. This is just a fun little non-Newtonian fluid that you can easily make.
I did this with my cousin before.
Yeah?
Yeah.
Cool. Do any of you want to share what you've observed?
Is she talking to me?
Do you want to share what you observed?
It's not working.
You have a good sense.
Yeah.
Mine was like super liquidy at first, but then I had to add cornstarch, and then it was better now.
That's
My oobleck is still absorbing all the water.
good. Is it taking forever to mix?
Mine wasn't ooblecky enough, so I had to add more cornstarch.
Gotcha. Well, sometimes science is a lot of trial and error. When you do an experiment, sometimes you have to do different amounts for variables because you never know what will work.
More cornstarch, more water.
You go to the Boy Scout.
So first, it was really liquidy. Then I put some more cornstarch in, and then it went just right. Now it's unbreakable.
If it's a little bit too hard, add more water.
It's not that hard. It's like, but when I punch it, it's like a brick. It almost hurts my hands.
Then there wasn't enough cornstarch. At first there wasn't enough water. Then there wasn't enough cornstarch.
This is not, it's not coming together as slime.
Wow, my hands are getting so sticky.
You know Brooklyn. What if we add yours into Brooklyn?
Ooh. Oh, that would be great.
Okay, feel hers. Like, feel that.
Can I feel Ronald? Can
Yeah.
I feel yours, Ronald?
Yeah.
Oh!
That might be good.
Okay. So
It's too liquidy.
if it's too liquidy, just add more cornstarch. That will make it a little bit more viscous. It'll thicken it up a bit. Okay.
Hi, Diana. Quick question. How thick is it supposed to be again?
Okay. It should be, okay.
Oh God.
If you're not touching it, it should be really kind of liquidy, but when you stir it, it should become hard. Like you should be able to put it in your hands, and if you squeeze it, it'll kind of take a shape, but as soon as you let go of it, it'll flow through your hands.
Okay, so we need more cornstarch. Okay. All right, awesome. Thank you. All right.
No problem.
I said it feels like soap. Feel my hands.
What do we do if we want to save it? Just put it in a
If you want to save it, then try putting it in a Ziploc bag. I'm not positive if that will keep it, but it'll stay fresher longer than if it were just sitting out.
Nothing happens when I put my fist into it. Should I use flour?
Flour won't work.
Okay. Should we add food coloring to it?
You can, but it'll also make your hands dye that color.
Oh, this looks. I think it would be interesting to have my hands a different color.
If you're welcome to dye yours if you want.
Me and my friend, we were gonna like put a scent into it and see what happens.
Is everybody ready to move on?
No.
You can still play with it. It's just going to be a little instructional video that teaches you about why Oobleck is how it is. Okay.
Yours is cold.
Okay. If you all wouldn't mind muting yourselves and turning off your mics so that we can move on to the next part so that we can wrap up on time.
Oh, this is a video.
Your mic.
Oh, okay. I'm not sure how to do that, so I can always just send you the link to watch this video and I can move on to slime if everyone's okay with that.
That works. If you unshare your screen, it's a box on that screen when you share it. So you'd have to unshare your screen and then reshare it is how you'd change it. It's just a box that says share sound.
Okay. Where is it? Sorry.
So when you're actually like when you click share screen, there's a box, I think it's on the bottom left, that says share sound.
You're gonna need to clean up this mess when you're done. Do you hear me?
Yep.
I think she's moving on to slime.
Oh, okay, I think I see it. Do you guys want to move on to slime?
Yeah.
Okay.
Yeah.
I'm not done.
You can still play with it. This is just going to be a small explanation, and then we're going to move on to slime, and then you can always play with it later.
I didn't finish it.
Are you done with this?
Yes.
I'm not done with the Oobleck.
So while everybody's finishing up, the states of matter are solids, which means that the substance has a definite size and shape, like a chair or a table. Liquids have a definite size, but they take the shape of the container. Like this water, it has a definite size, but it still fits my water bottle.
Okay, you got it, I guess.
And a gas, there's no definite size or shape. Like the air in your room, it's filling up the entire room. So non-Newtonian fluids, they have properties that can make them act like both a solid and a liquid. So the Oobleck that you're playing with, you could, if you squeeze it, it almost took the shape of your hand, right? And it was almost solid.
Yeah.
But when you let go of it, it became a liquid and it just oozed through your fingers. So that's what makes Oobleck so special. So now to move on to slime. The materials you're gonna need are school glue, 4 ounces, half a teaspoon of baking soda, and 1 tablespoon of contact solution. You can also add glitter, food coloring, craft foam beads, and shaving cream to make it fluffy. Okay, so the instructions, you're going to pour in the school glue, add in the decorations, and then stir in the half a teaspoon of baking soda and the contact solution. So here's a video.
Hi everyone, it's time to make slime. Okay, so first things first, we put on our safety glasses. Since this experiment can be a little bit messy, please make sure that your hair is tied back and try not to have anything draping over you, like a necklace or long sleeves. Okay, so for this experiment, you're going to need a bowl to mix in, a spoon to stir with, half a teaspoon of baking soda, 1 tablespoon of contact solution or saline, 4 ounces of school glue, and if you want to make your slime extra special, you can add shaving cream to make it fluffy, food coloring to dye it, and glitter to make it shiny. Okay, so first things first, we are going to pour in the glue. You're also going to want to make sure that you are working on a surface that you can get a little messy, so Try to lay down the tablecloth if necessary. Okay, so once you get out all your glue, you're going to want to add in any optional add-ins. So I'm going to be adding a little bit of shaving cream, just a few drops of food coloring, and a small shake of glitter. Okay. So now we're going to stir it. Make sure that you put in any add-ins before you do the next step. Make sure you stir up everything nice so that all of the ingredients are incorporated. So now it's a nice little blue. Except I didn't get the food coloring right there. Okay. Now we're going to add in our half a teaspoon of baking soda and stir that in as well.
This is much better.
You're going to start to feel it kind of thicken a little tiny bit. Okay. So the last step is adding the contact solution. So once you measure out half a teaspoon of 1 tablespoon of contact solution.
We're still stuck on the glue part, so maybe you could start from the glue part.
You're gonna get messy. That's why we have our last.
Do you want me to start from the beginning, or do you need me to just pause it for a bit?
Can you pause it?
Yeah, I can pause it. Just.
Wow. I mean, ready. Really?
Yeah, we do.
This is in the way. I can't. So. I think we're right here.
What if it's too gluey?
If it's too gluey?
Yeah.
Did you pour in the contact solution yet?
No.
Okay, so just wait. You're gonna need to add the half a teaspoon of baking soda and the tablespoon of contact solution, and that should make it thicken up.
Okay. But it is stretchy.
Okay, did you add the baking soda?
Not yet.
That's really weird. Okay, so basically, you're going to pour in the 4 ounces of glue.
I already did that.
Okay, then after that, if you want to put in shaving cream, glitter, or food dye, and then stir that in.
Hey, Hannah.
Yeah.
Help over here. My daughter accidentally added the ingredients to the Oobleck.
Oh.
So I have the glue. I have the baking soda. I have the baking soda. Contact solution. What is that exactly that I can get now? You have it.
It's saline or contact solution. You need 1 tablespoon.
1 tablespoon. And is that all we're missing except for all the fun stuff like glitter?
Yeah.
Okay, I think we're good. Hang on. I'll put us back off. I'm sorry.
It's okay.
What does the shaving cream do?
It just makes it a little bit more fluffy.
What would it do if you pour in the last thing? Will it still do it, or you have to pour it in the first
I think you have to pour it in before the contact solution and the baking soda, because the chemical reaction, I think, would have already taken place, so it wouldn't be incorporated.
All my supplies were on because like how it was sent. So like there's like a tiny bit of baking soda in the container.
Yeah, you're supposed to mix in the tiny bit of baking soda. That's a ½ teaspoon. If you got a STEM kit. If you requested a STEM kit, yeah, you're gonna put in the 4-ounce container of glue, the ½ teaspoon of baking soda, and 1 tablespoon of contact solution.
Going forward, I wouldn't put liquids in this.
Yeah, that's the contact solution.
It leaked everywhere.
It leaked everywhere?
Yeah. I was mailing 3 separate containers.
That's the amount that you need.
Well, they leaked all over everything, is what I'm trying to tell you.
Oh, I'm so sorry about that.
They're not very good for shipping.
Okay.
Can I don't think we have any contact solutions, so would an eye drop solution substitute?
I have no idea. I mean, you can always try it.
Yeah, it's got like glycerin. Is there any other substitute besides saline per se?
Okay.
If it's mostly saline, it's not mostly saline.
Yeah, using that can just
A lot of times, if they have younger kids, they might have saline no spray. So if they don't have liquid saline, that's just in a bottle, they might be able to use some of that.
Well, I didn't catch what she said.
There's also like the saline, the nose spray.
Oh.
Kids or the younger kids have that, so you might have that in the house.
Yeah, or I can just do salt and water. Somebody's saying, can I just do that?
Concentration.
All right. We needed. Was it a tablespoon or a teaspoon?
It was a tablespoon.
All right, we're gonna experiment. Oh, good.
More.
Thanks.
Just mixing it with my hands. I just made mine purple. It's red and blue. It's like the best slime I've ever made.
I'm glad. From what I can see from people's videos, it looks like a lot of you got it to work really well.
No, this is my dad's computer.
I think that we're supposed to pour this.
That's my dad's computer.
Hi, I'm Soraya. Miss Hannah. Look what I made.
I don't know if I'm seeing the correct person right now, but everyone who I can see, your slime looks amazing.
It's blue. Oh, it looks.
Mine's purple.
But it's about to turn red.
Oh.
We're supposed to pour this, right?
The what? Sorry, I can't.
So that is for
The flour? No, the flour is not for the slime. That's for making Play-Doh.
Okay. Did we make it over again? Do you have the? Oh,
I could actually. You're right.
we have glue. We have everything.
But I'm gonna say.
Okay. A good idea. Good idea. So that is going to go.
You made moon dough before?
I'm going to grab something that's foolish. Oh my gosh. Oh my gosh.
Oh, the slime worked really good.
Look, we took it out.
I just put my slime in a bag to save it.
That's a good idea. That'll keep it for a while.
Oh my god.
Now I need to make the mess I made in the kitchen.
I'm not putting mine in the basket. No, this is just for like putting. Yes.
Got lots of napkins to clean up.
What's on your head? Can you get the plate things that we can shape it with?
What?
Lego does. This is the best thing! 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 This is awesome!
Amazing.
I'm glad you guys like the slime.
That was my experience of slime.
This is awesome!
I'm glad.
I finally get my own. Oh my gosh.
It's gotta be a good slime recipe out there that actually is good.
Yeah.
Oh, it's getting together. Okay. Oh, jeez.
While you guys play with your slime, I'm going to move on to the next slides. It's just an explanation about non-Newtonian fluids. You can continue to play.
Okay.
There, I say it. I think they're.
I'm gonna go wash my hands because my hands look like purple.
If everyone wouldn't mind muting their mic so that we don't have any crazy noises. Thank you. Okay, so how does the slime form? The molecules in the glue in the contact solution, they combine, stick, and bond together to form something called a polymer chain. So the big question for today, what is a non-Newtonian fluid? So that word is viscosity. Viscosity is a substance's resistance to flow. So basically, water is less viscous than something like honey, because water is easier to pour. The viscosity of Newtonian fluids, which are basically normal fluids like water, are only affected by temperature.
Don't open everything because this one's already open. See?
Like if I stir water, it's not going to become harder to pour. It's still going to have the same viscosity. However, if I cool it down or warm it up, it may be easier to pour or harder to pour. Generally, liquids become more viscous when they're cold and less viscous when they're heated. The viscosity of non-Newtonian fluids, which are like Oobleck, can be affected by something called shear stress. Shear stress is basically squeezing, hitting, mixing, or adding pressure to the fluid. Shear thinning fluids decrease in viscosity upon the application of shear stress. That means when you stir it, or shake it, or even hit it, the fluid will become easier to pour. If any of you have ever seen ketchup like in a glass bottle, it's very hard to get out of the container because it almost like appears like it's a solid in the bottom of the container. However, when you hit it or shake it, it comes out easier and it becomes less viscous. That's because when you apply the shear stress, like hitting the bottle, the bonds are broken, so the fluid flows more easily out of the container. Shear thickening fluids are the opposite of shear thinning fluids. These fluids, they increase in viscosity when you apply shear stress. So when you mix it or hit it, it becomes harder and it's a lot harder to flow. So the Oobleck that you guys just made, the cornstarch in the water, when you punched it or when you tried to stir it, it became harder, right? It almost appeared like a solid and you could hold it in your hand if you squeezed it. But when you let go, it would flow through your fingers. That's because it's a shear thickening fluid. So when you hit it, the viscosity increases. And with shear thickening fluids, they become tangled with one another. So this is a demonstration that I'm going to be showing you. And here are the instructions if you want to try to do it in the future. This is the video.
Hi. So this is an experiment to demonstrate viscosity. Viscosity is defined as a substance's resistance to flow. So what I have here are 3 test tubes one with water, one with vegetable oil, and one with dish soap. I also have a set of polyhedral dice. What we will be doing is opening up these test tubes and dropping dice into each one at the same time. We're going to see how quickly they sink to the bottom. And the faster they go, that means that the liquid is less viscous. And the slower they go, that means that the liquid is more viscous. So, without further ado, so as we can see here, the water one sank to the bottom first, the oil sank later, and the dish soap is a very viscous liquid. So the dye is taking a very long time to sink. Okay, so what we learned here was that the water is less viscous than the oil is less viscous than the dish soap, and the dish soap is the most viscous of them all. Thanks.
Okay, well, now that everybody knows what viscosity is and how non-Newtonian fluids work, we're going to have some more fun and we're going to make some Play-Doh. How's that sound?
Yes, sir.
So what you're going to need is 1 cup of flour, a 1/4 cup of salt, 1/2 cup of water, make sure that the water is warm, and a tablespoon of oil. So I'm going to mute everybody real quick.
Can you?
It's okay.
Can you put my ingredients in the chat?
How was mine gonna turn to slime?
Mine is so hard. Mine is so hard. But you keep it doing this.
I got it right. Okay.
I think everybody's muted. Okay. So this is the video on how to make Play-Doh. Oh wait, my bad.
Hi everyone, it's time to make Play-Doh. So first things first, put on your safety glasses and gather your ingredients. For this experiment, we are going to need 1 cup of flour, a 1/4 cup of salt, 1/2 cup of water, and a tablespoon of vegetable oil. You're also going to want a spoon or utensil to stir and mix with. And you can also add food coloring, but I don't recommend it because it's very hard to incorporate and it just ends up dyeing your hands. Okay, so first things first, we are going to pour in our flour. Be careful, otherwise it's just gonna like fly back at you. Okay, so next we are going to add our salt. Make sure you mix it really well so that everything is evenly distributed. Okay, after you do that, you're going to use water. I recommend using warm water, but I forgot that, so I'm using cold water, so it might not work out as well. So slowly pour in the water and mix really well.
Just so that everybody knows, it's 1 cup of water, 1/4 cup of salt.
It's going to be a little bit hard to
1/2 cup
mix,
of
so
water.
just be
Make sure
patient
the water is warm.
and keep trying to
And you're
incorporate
also going to
everything.
want a tablespoon of oil.
So eventually you're gonna kind of get to the point where the spoon's not gonna do much. So you're gonna need to use your hands to help mix everything together. Yeah, I should have used warm water. Okay. So you're gonna kind of knead it together and try to get everything mixed up and stuck together. If you don't like the smell, you can also add some essential oils to kind of cover the smell of flour. Okay, so once you incorporate everything as much as you can, you can add the oil. It's a little messy. So try to get it evenly distributed. And you're gonna wanna mix everything.
How much oil are we supposed to add?
And with the oil, everything should start coming together. You're gonna notice that it feels a little bit gritty, but once you work with it and play with it for a little while, it'll become really smooth. Okay, awesome. So now we can see our Play-Doh. It's a little bit, it's kind of weird. It's like dry, but also oily. But you can roll it and make shapes of it and have a great time. So
We don't have enough salt, so could I put in more flour?
If you don't have enough salt, then just don't add more flour. Just use as much as you can, or if anything, use less flour.
Okay.
And use a little bit less of all the other ingredients to compensate for that.
Can you type the ingredients in the chat?
I can go back to that slide. Will that help?
Yeah, thank you.
Yep, no problem.
Krista, do you want me some?
Okay, so the science behind Play-Doh, wait, I'll just check the chat real quick. Okay, so the science behind the Play-Doh. Basically, at first, some physical changes are going to happen. You're adding the flour and the salt, and this is creating a mixture. And when you put the water and the food coloring, if you put food coloring, that's creating a solution. So these are examples of physical changes because nothing is being created. The items, while it would be hard to separate, they are still separable. And when you combine all of the ingredients together, a chemical reaction is occurring. This means that something new is being created. Chemical changes, new products are made, and you can't undo the reaction. It's like wood burning. You can't unburn wood. So basically, part of the science behind the Play-Doh is that there are these proteins in the flour, and they clump and stick together. And these proteins, they hold the water, and that creates the Play-Doh. And second, I'll check the chat again. If it's not sticky enough, is it too dry? or is it too? It shouldn't be super sticky. You could always add too dry. Okay, if it's too dry, then add either a little bit more of the warm water or the oil.
It's actually too wet.
It's too wet?
Mine's is actually too wet because mine's is not working. It's not going together.
If it's too wet, try adding more flour or more salt. And can I go back to the ingredient side? Sure.
What if it's too sticky?
If it's too sticky, like it's sticking to your hands,
Yeah.
try adding a little bit more of the oil.
Whisper, no, you don't.
It's also going to feel a little bit gritty at first, but once you play with it for a while, it becomes a lot softer. Speaking from personal experience. What is that? Sorry, technical difficulties. That is not. Okay. If yours is too watery, again, just add more flour or salt, and hopefully that should fix it. Okay, so that's physical and chemical changes. So to wrap up, I hope that you all enjoyed this first session. Thank you for bearing with me as we face some technical difficulties. I encourage you all to RSVP for our next session next Wednesday on July 15th, same time, to learn about how you can make your own elephant toothpaste and make your own miniature lava lamp. I also encourage you all to please check out this project's Flipgrid board for fun STEM challenges. And I can take you out there real quick just so you can see. It's set up so that if you ask your parent or guardian for permission, you can do these fun challenges and upload small videos of building the tallest paper tower, making a boat out of aluminum foil and seeing how much it can hold, making your own powered car with balloons or chemical reactions, trying to drop an egg to see if you can make a contraption that will protect it. You can also use curved chips like Pringles and make a ring. And there's also going to be a virtual science fair.
Oh, we could check out my other thing. Thank you. Thank you. Thank you. Thank you.
If you guys have any advice on how I make this session go better in the future, please email me and I'll try to take your advice.
Thank you. Thank you.